Hello. So in this video, we are going to be doing some computating and some graphing of piecewise functions. So in particular, we're going to be going through how to calculate, various points in a piecewise function, and then how these things are actually graphed in practice. Okay. So let's say we have the following generic sort of piecewise function here. So we have this function here, and it is, right? So we have this x plus 1 from -3 to 1 and square root of x minus 1 for x bigger than 1. Now, keep in mind these less than or equal versus less than, right? These inequalities, because whether or not they are strict actually makes quite a sort of important difference, both for calculating and for actually doing the graph, okay? So we could really do either one of these functions first. I tend to try to do the ones on the left first, but we'll see examples in this video doing whichever one first, just so you can see that it really doesn't make any difference. So here, I want to pick some sort of value, right? If I'm given some endpoint, so here I have that goes from -3 less than or equal to x, strictly less than 1. So here, since I'm given -3 as the sort of far leftmost point, I'm going to calculate it at that value. So I'm going to plug in -3. And what that means is that when I try to plug in -3, I'm going to look to see where -3 falls in my domain, which is right here in the red top one. So then I would plug it into this top piece here. So that would give me -3 squared plus 1, which is 10, right? So this tells me that at x equals -3, I have y equals 10, so that gets me a dot up here. And of course, this thing is going to be filled in, right, because it's less than or equal to. Now, the next part is a little weird. So I'm going to calculate f of 1 in quotation marks, because really what I want to do is I want to figure out what this top curve is. And even though, right, it's really important that this thing is strictly less than 1, what it's telling me is up until 1, it's going to look like this top function. So I don't want to say that f of 1 equals and then this top part, right? Because if I actually want to plug in 1, I'd have to go into this bottom part down here because that's where 1 actually is. So I'm putting in quotes because I'm going to plug into the top equation because what I'm trying to do is get everything up to that value. So what I'm really abusing here is this idea of continuity and something called one-sided limits, which we're not going to talk about in this class, but it will show up very early in calculus if you go on to Calc 1. So I'm sort of hand-waving a little bit here when I'm doing this f of 1 and plugging it into the top equation rather than the bottom equation because I'm trying to figure out what it is going toward up until 1. So to do that, I'm going to actually evaluate 1 in this top one, but I'm going to graph it instead as an open circle rather than a closed circle, right? Because it's strictly less than. So when I plug in 1, I get 1 squared plus 1. That's just 2. So that tells me that at x equals 1, y equals 2, that's sort of what I'm going up to for that top equation, but I don't include it. So that's why it's an open circle. And if I wanted to, I could plug in more points to get a better idea. But if I know what this thing looks like, which I kind of do, right, because it's a parabola, just x squared shifted up by 1. So then I can draw in that piece of the curve, right? So this gives me the top equation part from -3, right, the x equals -3, up till 1, but not quite including 1. Then I want to do the next part, right? So actual f of 1, because now, right, when I'm plugging in f of 1 here with the green part, I'm actually calculating the real f of 1, because this does include 1 here. That's going to be the square root of 1 minus 1. That's just 0. So that tells me that when x equals 1 and y equals 0, that's an actual closed dot, right, because that's where it's equal, right, because x is greater than or equal to 1, or 1 is less than or equal to x. And maybe I want to do another point if I'm not sure what this thing looks like. So I could plug in 2 just to get another sort of value that I could use. So if I plug in 2, that gets me 1 as the y value. So that gets me x equals 2, y equals 1, another closed dot because it is included. And if I'm still not sure, I could even plug in a third point, right? Because the idea here is not to only put in specific points like these magic, transition points or endpoints or things like this. It's to plug in enough points that I know what the shape is, right? So if I plug in 5, square root of 5 minus 1, square root of 4, which is 2. So at x equals 5, y equals 2, I get another dot. Now I can definitely connect these and make a nice sort of square root function over there. And so this would be the graph of this piecewise function. All right, so let's look at another one. So let's say we have this g of x where I'm looking at log base 2 of 1 minus x when x is less than or equal to 0, and it's 2 to the x plus 1 minus 2 when x is greater than 0. Now again, before I did the sort of top equation, the one to the leftmost, I did that first, but there's no reason I have to do that. So here I'm going to do the one that's on the bottom, the one to the right sort of part of the graph first. And just like before, I know that it's sort of 0 is this transition between the two things. G of 0, if I plugged in 0, I get the green equation, but I'm trying to do the red equation here. So I'm going to do, quote unquote, G of 0. I'm going to plug in 0 to this bottom equation, but that'll give me the open dot version, right? So it's not that it actually equals that part. It's that I'm sort of doing it up to that point. So when I plug in 0, I'm going to get 2 to the 0 plus 1 minus 2. That's 2 to the 1 minus 2, which is 0. So this tells me that at 0, if I'm looking at sort of the right part of the graph, the red part here, I'm going to have the x equals 0, y equals 0, but it's an open dot because this thing isn't actually equal, right? This is x greater than 0, strictly greater, not greater than or equal. So this gets me a nice 0, 0 open dot piece here, okay? And again, if I'm not sure what this thing looks like, I could plug in another value to the right, say 1. That would get me 2 to the 1 plus 1 minus 2. So that would be 2 squared is 4 minus 2. That's just 2. So then 1 comma 2, that gets me a nice closed dot up here. And this thing's an exponential, so it's going to go up and away, right? So that's the right-hand side. Now, the left-hand side, or the top one, right, our green function up here, I'm going to do the same idea. I'm going to plug in 0 as my starting value, but now it really is plugging in 0, right? Because that's where, right, I have x less than or equal to 0, so it really is that value. That gets me log base 2 of 1, but that's just 0. So notice here now, I'm going to get 0, 0. So before I got 0 and 0, and that gave me an open dot, right, because it didn't include that value. But now I'm going to get 0 and 0, and that does include that value, right, because it is less than or equal, right, equal to 0. So this is actually going to fill in, that 0, 0 is going to fill in this open dot over here. So that ends up sort of filling in that value, okay? Then, again, if I know what this thing looks like, it's a log, basic log shape, I could just fill this in, or I could plug in more points depending on how it works, like whether or not I know what this looks like. But this is end up being the shape that I get, okay? All right, so let's try sort of a slightly more complicated version here. So instead of 2, let's go with 3 different ones. So we have sort of these 3 different rows, right, which are 3 different functions and their corresponding domains. So for this top one, I have this radical, right, and it applies for any x less than or strictly less than -1. Then I have this quadratic, which is less than for x greater than or equal to -1, but strictly less than 1. And then I have this exponential for x strictly larger than 1, okay? And again, the order that I graph these doesn't actually make a difference. So whichever direction you feel like doing it, that's fine. I'm going to start with that the same sort of left to right, which is how I usually do it. But again, whichever one you like. And remember, I want to do sort of the transition points and enough points to get a good idea of how this thing looks. So I'm going to start with -2, plug it in, calculate this whole big mess, gets me 1 as a result. So I know that I have a point at -2 comma 1, and it's filled in, right, because it does include that point. Then I'm going to plug in, quote unquote, h of -1, because really, again, what I want to do is plug in -1 to this top one, but that's not quite right because it only applies when x is strictly less than -1. So I'm trying to figure out sort of what it goes to, even though it doesn't include it necessarily. So if I plug in -1 to this mess, sort of punch it all the way through, I get 0. So that tells me that -1 comma 0 is a point, but here, right, it's a empty circle, right? I don't fill it in because this isn't included, right? It's only x strictly less than -1, not less than or equal. And I can connect these things to make this sort of relatively nice radical function curve on the left. Then I need to do the middle part. So I can plug in -1, which is included, right? -1 is less than or equal to x. So I can plug in -1, negative 1 squared plus negative 1 is 0. So then I get negative 1 comma 0, which means, again, I'm going to fill in this dot over here. So filling that in, that's one of my points. And then, just like before, I'm going to quote-unquote plug in 1, but it's not really because it's not actually included. So I'm going to have this quote-unquote h of 1. So I'm going to plug that into the green equation. Gets me 1 squared plus 1 is 2. And this gets me the 1 comma 2, but it's an open circle, right? It's an open dot because it's not actually included. And this thing looks like a quadratic, so it looks something like this, okay? And last but not least, I want to do the purple, right, the exponential. And again, the 1 here is also not included, right? So it's 1 strictly less than x. So I'm doing quote-unquote h of 1. So I plug in 1 here. I get 3 to the 1 minus 2, which is just 1. So that gets me 1 comma 1. Again, open dot because it's not included. And if I'm not sure what this looks like, I could plug in 2. That would get me 3 squared minus 2. So that's going to be 9 minus 2 is 7. So it's way up top somewhere. So that tells me it just sort of goes up, up, and away, right? But notice here that I have, right, I've graphed the red part, I've graphed the green part, I've graphed the purple part. And I did that by graphing these transition points. But even though 1 was sort of an important transition point, right, I did it twice, it wasn't actually included here, right? The purple one only applies when x is strictly bigger than 1. The green only applies when x is strictly less than 1. So h1 itself is not actually defined. It does not exist. It doesn't have a value, right? Even though I've sort of quote-unquote calculated it, meaning I plugged it into the other ones to get these open dot values, I don't actually have a value of h itself at 1. Okay. All right. So what do we do? Well, we looked at how to graph these different piecewise functions, and sort of necessarily we talked about how to compute them, right? So we would plug in the values into whichever function sort of correctly has those, with that little bit of an asterisk where sometimes we plug in transition points, sort of quote unquote, right? We plug them in where they weren't technically equal, but we were doing that so that we could get the open dot form, right? It goes all the way up to that, but doesn't quite include that value, okay? So we did that for computing and then sort of glued together, right, the different parts of the different functions by basically just graphing one function, then the next function, then the next function, however many there were, and putting it all together in one graph, okay? So that is that.